Okay, we're going to see if we can pick up this conversation of that quantrino or the axion. I actually drew some circles on these, so it might be able to help us out later. Do some other things, but for right now, we're actually going to put those off to the side. That is too complicated for you right now. You are not ready for high-level math like that. You just, poor monkey brain, not going to be able to handle it. So, how do we deal with this? How do we deal with this problem that is whatever thing is? Well, we need some observable plane state to deal with. Well, what's a plane, Jordan? And like, well, we got together and we're like, that's a blade of grass. Like, this is a pencil. Okay. Let's start from here in the math equation. Z overlined A prime, right? Or AA. Whatever. Somewhere's in there, we both know that that's the math, or at least some portion of that math is correct, right? All right, so anyways, what's that mean? It means, well, basically, I'm acceptable on that. It has different concepts of this thing, this thing, this thing. It's a piece of cardboard that's all weird shaped like life. Yeah, okay, great. Let's at least deal with the value of it's not that, but at least deal with the concept that it is this. So what do we do first? Well, we say, all right, so we quantified these two axes. The direction is here and here, and if I throw them in time, they will continue to do that, or they will have post time to go back to Big Bang singularity states of this having an axis, right? So what's the axis that we do? Well, generally I'm in the universe. I would assume, well, not the center of the universe. I'm pretty centrally located in the middle of it, at least for my observing principles. Yeah, so let's just put a dot on there, a Big Bang, something happened, just a little singularity, nothing at all, but generally in the middle of it all. Right? Just a little dot. There's a little dot inside of there. So why would you do that, Jordan? Well, generally, if I want to find any increment of a system, I need to have increment numbers of this, me and this pencil, and they have different values, and if I trebuchet them, they both do a very different thing in effect of generally where they're located in the universe, because that'll change things later. So what's that mean, Jordan? It means, well, we have to find a way to fold those problems, to make them the same thing in superposition with one another. So it really doesn't matter. We haven't given it any defined concept or name yet. So let's just fold it in half. Generally in half, close to half as you can get. So just make sure you're hitting it from that crease. You know, I'll start on the edges. We're actually starting it from the singularity here. We're going to start that in there, this cosmological constant problem. We're going to fold space, right? Not a perfect fold yet. We don't know squares yet. We're not that far. We know lines and dots and numbers and letters and increments of changing those things over on axioms, I's, E's, antiphotons, gluons, so on and so forth. At any rate, inside here, well, we know that's correct, and we know that they have time symmetry. We know that this idea from this idea can be, or there's some level of this line just expanded quite radically on its properties. It's just saying, well, it's from here to here about here. And so we built a few dimensions to deal with what I have here. So what we know is that everything's going to have symmetry, at least anti-symmetry, the forward and back, top and bottom. Those are going to be our anti-symmetries in here, but we're not exactly sure as to what measurements that is. And so if you're careful there, we actually have to first determine what an increment of measurement is. We know from a singularity to the extremities of the system that, whatever system that may be, that would be what 1 or 1/2 can quantify to. It is this long, at least on this axis, and if you change that axis to any axis on here, any fold, that length is going to change if I take and I fold and fold and fold. It eventually give me that, but I'm not going to beat up this cardboard right now. We want to have that square axis on here, because eventually we want to use this to make a ruler. And with that ruler, we'll be able to break off a corner inside here to actually make a square. Alright, some way where I can then say, well, with all those folds and ripples and systems in this fluid, or this singularity, or this pressure ampule, as it were, I'm a little off because I'm still playing with the Carl Sagan universe loaf of it, so bear with me. I was trying to practice run. Pretty good intro. I like where it's going for Carl Sagan 2D land stuff. You know, this is that singularity that actually, once you build all that, you can say, well, now I know what an increment is. I can invert from the start of that, not deal with the limitations of it as something's compressing that value, changing its color or temperature or some system where the axes of those things would all give it defined value. No matter what it was inside of there, there would still be on a 3D engine for sure. In the parallel here of these things being equal or inequality for the exclusionary principle. Obviously, they're not the same thing. This is going to lens this all out into what happens while you deal with this. But again, basically, it's some kind of very simple folding of two planes: a measurement, a motion, and a position. Right, a momentum and a position, a momentum. And I'm not exactly sure which ones are which yet, but it's still a sphere here. It's still one radiant, one relative system inside here, but no way to connect it with a bond. If I have that bond, I can make a circle, but I don't have that system. I have just this lensed out beast of a math problem inside of me, or the stone mill, or this rabbit I can't get on the farm. There's me and the rabbit and something I want it to do. And generally the system is, yes, that does give you your quadrants, two plane states at X and Y. Come over here. You're not going to notice it from certain axes, but in anti-symmetry to what that does, this might be the value, or I need to add, or I don't know if I can get a subtract. Well, sure. I can add, subtract, or multiply, divide any of that system on its axis, and that's what the defined definition, as long as that paradox isn't mirrored or antied in some way for relative reasons within the conversational cosmological model. So we can fold this up here real quick and actually get our little axion, which is still quantrino, right? Because we're taking this plane state and we're folding it to actually make it to this neutrino, or vice versa, or axion. Neutrino, zero states. I'm not sure which value it is. It's Bose and Fermatic inside of here for how it's behaving. Now, what are the reactions of it? Well, it's how you orientate them as you slide them together. Well, anti, up, 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 down. It would be that limit inside of there for what kind of values. Hold on 1 second here. Well, I'm curious. I'm walking the walk, bro. You find out what you can do with it, and where you go with it for, what kind of symmetries, axis. Is there any kind of 3, N1, M2, M3? Obviously in a hypercube like this, the matrix is going to get a bit more compounded under, what kind of principles you may be looking at for describing general plane states. Again, we go back to the original principle. It can still be a minus. I think it can even, well, certainly a Feynman. Depending on how that function values or is relatively observed, radical things change based on how that might present itself. I don't know what, it doesn't take a lot of pressure, just a very weak pressure to do this one, but it gets to the point where you would need to counter that reactant like you would the strong force before it breaks and turns over. And those mean things. Each physical action and step is going to play to the genesis of certain operations that you do with a thing. Now that I've built this thing, I'd say, well, there's the stone mill, my position in it. Maybe that's an axis of it or a parallel about it. In certain matrices of it, this quantrino, and how it's behaving. It's going to behave mirrored. Am I paying attention to those axes while dealing with the 3-part problem, the 5-part problem? Is it a Feynman diagram of being, let's see if I can recreate it here, being this form of the diagram? Or is it Feynman in the fact that it's going to be this form of the diagram? Or potentially, let me see if we can do that better. See if we can get a yeah, maybe a little closer, maybe. I don't know. Well, basically, again, you would see energy out, and this is the fuzz. Now, the distance between those two is springy. Catch you on the next one.